Hi everyone, welcome back. So we're gonna be starting off from the beginning. Last time, the last two videos, I was mostly focusing on the sociology aspect of the sheet, but I am now starting from the beginning. So be sure to catch up my first two videos for the sociology section. So let's get started. I hope you guys find this videos helpful. I just wanted to teach myself the material. And while I was teaching myself, I didn't really have anyone to teach. So I thought, why not just record these on YouTube? Maybe it could be helpful to someone. Me talking, this could be helpful. So please, thank you so much for watching. I'm so happy if I could help you. But I definitely suggest putting this on 2 times speed because I do talk very slow. So we're gonna get started. So we're looking at sensory perception. So first we have visual cues and things that we need to look out is depth, form, motion, and consistency. So when it comes down to depth, it's basically how far something is. Form is what shape, structure something is, and motion is basically when we're thinking about movement. Consistency is telling us about the object and how stable it is, such as size, shape, and color. Binocular cues, it's in the name. So when I look at binocular cues, I'm thinking of two things. Two, by two. So two terms I'm going to be remembering. Retinal disparities and convergence. Retinal disparities is basically saying that the eyes see things slightly different image because the eyes are a few centimeters apart. So what that means is when we're discussing retinal disparities, we're just knowing that we're looking at two different images because of our eyes being centimeters apart. Conversion is a little bit different. So it's basically looking at muscle movement and strain, particularly the muscle movement of the eyes. So you could basically have your finger, right? And you point it in your nose. You could see how your eyes will move inward. And that is basically what conversion is. And you pull your finger out and you could see that your eyes is not converging. So what it's saying is that your eyes turn inward when focusing on close image. So your eyes, right? Your nose, pointing at your nose, and you could see your eyes moving inward. So the closer the object, the more conversions we have. While the further the object, it's going to be less convergence. Molecular cues, there's a lot of terms that we have to know. But when it comes down to studying on your own, I definitely recommend actually looking at not just the term, but actually pictures of each molecular cues because they could ask about, they could show you guys a picture and it could be like, hey, what is this showing? Is it relative height? Is it interposition? So knowing the term is important, but also in your free time, please be sure to look at the pictures so that way, if they were to test you, you are able to answer the question. When it comes to molecular cues, you have things like relative size, interposition, relative height, things that are higher or further away. You have shading and contouring. Like some pictures, you could have shading, some object could have contouring that makes them look different. Motion paralyzed. Every time I see motion, I'm thinking about movement. So things further away seem to move slower. Consistency is basically how we see an object. So we have size consistency, shape consistency, and color consistency. Our body main goal is to adopt. Um, you could put your body through so much and it's gonna do everything that it can to adopt. And It does it through sensory adaptation. So we have hearing. So once you hear a high noise, your ear muscle will contract. We have touch, temperature receptor desensitize, smell, also desensitize. So imagine you walk into a room, right, and you smell something so yummy. Eventually, you become desensitized by that smell, and you don't smell it as much when you first walk in. For perception, we're going to talk about it more. It's going to be your body would adjust. So if we look at a mouse and we put it upside down, your body would actually adjust over time and flip it over. Sight, so typically a physician will look at your pupil to see if it's going to contract, if light or comes in. So that is one way that we're adapting. So if there's a light coming in, your pupil will contract versus if it's dark, your pupil would dilate. Rods and cones are important. So typically with rods, you're gonna have black and white. It's mostly black and white we're talking about, while cones is always about color. So cones, CO, color, CO, color. So this is how I view it. C for color, CO for color as well. So cones, color. Rebet law just talks about the thresholds of what we're able to notice. So just noticeable differences is basically the threshold that you are able to actually notice in sensation. While we have absolute threshold of sensation, it's the minimum intensity of stimuli that is needed to detect 50% of the time. Subliminal stimuli is stimuli that is absolutely below the absolute threshold. So we're talking about vestibular system. So when we're talking about the vestibular system, one thing that is important to know is the endolymph. So the endolymph just basically allow us to detect direction when our head is moving. Autolytic organs helps detect linear acceleration and head position. So it's important to know that, let's just say you're spinning yourself around, right? You're spinning, you're spinning, you're spinning, you're spinning, you're spinning. You're spinning yourself, you're spinning, you're spinning, spinning. Just think of yourself as a little kid. I used to do this all the time. You start becoming dizzy, right? The reason why you become dizzy is because your endolymph doesn't stop spinning at the same time as we do. At the same time, our brain tells us, hey, we're done moving. So it contributes to dizziness. So the reason why you feel dizzy is because your indolent doesn't stop spinning the same time as we do. So it continued moving, and it tells your brain, hi, we're still moving, even though we stop. So that's why you feel dizzy when you're going around, 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 around. It's because of your indolent. Signal detection theory, basically what it talks about is how different signals are detected. So hit is like your um you have a strong signal, while miss you have like a weak signal. How have you bottom up and top down processing? Bottom up is basically stimuli influence our perception. And the main thing to know is processing sensory information, while top down is background knowledge, influence perception, and cognition is what is needed. So I think of top down as far as my head top. My head is always on top and it's always going to involve cognition. Well, I think of bottom up is just a process of sensory information. It's starting from the bottom. So when you're starting from the bottom, you have to have influence of your perception. You have to look at other things outside of your cognition. You have to look at the process of sensory information. So I think of top down is from my top is my cognition, from my bottom up, it's like my processing sensory information. Gestal principles are extremely important. Just like I mentioned when it came down to the molecular cues, it's also important to really look at the picture because I could talk about it, but the best way to understand it is by looking at the picture. So I would talk about it, right? But I'm going to go on YouTube, not on YouTube, I'm going to look on the web to show you guys some pictures. But when we talk about similarities, it's basically the atoms that are grouped together. The brightness is basically reducing what we're looking at into simplest forms. So, example is the Olympic ring. Proximity is basically the object that are close together or typically grouped together. Continuity is a line that we see and we just form it as like our smoothest path. Line or seam following like the smoothest path. Closure is object or grouped together as seen as a whole. So you see like an O, it may have some dot or something, but because you're used to seeing O, you just automatically make it as a whole. So I'm gonna show some pictures. As we could see, let's do MCAT. Okay, guys, so as you can see, right, you have contouring. This is contouring. You have similarities. I think it's important to pay attention to similarities compared to proximity because they're often could get confusing. You can see how we have proximity where it's just the shades and the box are like literally the same color. So that's one way you could detect proximity versus similarities. But similarities, you do have different shapes. So items similar to one another are grouped together, while proximity are objects that are close together are grouped together. So you see, completely different. So pay attention to these two. Closure, we could see that's a O, right? As I was mentioning. Continuity, common fate, those are typically what I'm always seeing, like the contour, the similarity, the closure, the possibility, continuity, and common fate are constantly being asked um, when I'm taking practice tests and doing practice questions. So now let's move into eyes. So it's important to know that the conjunctiva, I'm pretty sure I'm saying it wrong, is basically the first layer of the light that hits. Your cornea is going to be your thick sheet of tissue. And then we're moving on to the interior. So things to know is that the interior chamber space is filled with aqueous humor, which basically provides pressure to maintain the eye. So the aqueous humor is what provide pressure to maintain the eyes. Your pupil, as we talk about, is a hole made by the iris, which determines the eye color. So eye color, pupil. Lens is what bends the light. So it goes back to the eyeball. My old job just literally gave me notification. Um, since where were we? We're here. Suspensory ligaments attached to lower muscles. These two work together to form the ciliary bodies that secrete the aqueous humor. So posterior chambers is basically the area behind the ciliary muscle. It is filled with the aqueous humor, and as we mentioned, aqueous humor is what is used to maintain the shape of the eyes. Vitreous chamber is filled with the vitreous humor, but it's like a jelly-like substance, and it's basically what provide like that provide pressure to the eyeball. Every time I see choroid, I'm always thinking about blood vessel. Scala is just the white part of the eye. So to bring it back, we have the aqueous humor. That means pressure to maintain the eyeball. We have the ventris humor, jelly-like substance, also pressure to maintain the eyeball. Choroid, every time I hear blood vessel in the brain, choroid, baby. It's choroid. Blood vessel, choroid, okay? Pretty sure I'm saying it wrong too. So right now, things to know is that you do have macula, which are special parts of the retina. It's rich in cones, but fovea is our main girl. Fovea is completely covered in cones, no rods. So, like when it comes to sensation, when it comes to the eyes, it's just light and pulse photoreceptors. Things to know is that um so when we have lights that enter like the pupil, like it goes to the retina, which has rods and cones. So retina has your rods and cones. Rods are very good with night vision because we rods are typically black and white, and cones are really good with color. So like cones color, CO color, C for color. We're gonna have our three type, which is red, green, and blue. Cones is our girl. Fovea have our cones back. Fovea and cones, they go together. Okay? Cones and fovea together. If it says what where can we find cones in this experiment? You gotta call the boo fovea. Fovea is our boo. Okay? And just like anything that goes into your body, it has a cascade, a reaction um, of receptors, proteins that make it happen. And our cascade has to do with, with, for example, rhodopsin is one of the proteins that will bind to a molecule called the retinol, and the retinol will react if light comes in, if light does not come in. This is a lot of biochemistry, so I'm going to skip it. I probably would talk more about things like this if I do the biology section. So as we mentioned before, we're back with the rods and our cones. It's very important to know that cones and phobia, they go together. They're always together. Um, so rods would contain, um, so when we have rods, it will contain um, rhodopsin. Cones is also familiar, but it will have photosine. I'm trying to see where it's right here. Yeah. So rods would have rhodopsin. It's important to know it's RR, rhodopsin, while cone would have photosine. And a great way to remember this is that you always want your photo in color. So photopsin. Cones gives you color. It's always working with its fovea, photopsin. And um, it's important to know that rods are, you know, so sensitive to light than cones. That's pretty much it. It's good to know that your optic nerve connects to the retina, and blind spot is basically you have no cones and no retina. And rods are mostly found in the periphery. So rods, periphery, cones, fovea, fovea. Um, and there is so much rods than cones. There's about like 120 million rods and about 6 million cones. So it's important to know that we have things like trichomatic theory, um, focuses on color vision, and parvo-cellular pathway is really good for spatial resolution, but extremely poor with temporal. Magnell, I think of M, is very good with temporal um, resolution, but very poor with spatial resolution. Parallel processing is important, so you should see all at the same time. All the stimuli are coming together. Now we're back. We're in sound. Things that we have to know for sound is that we do have sound wave, and basically sound wave basically tell us if things are closer apart or if they're together, and frequency is how we measure sound wave. So if they're close peak, there's going to be frequency. And it's important to know every time you're thinking about the sound, there is one important term to know, and it's not coming to me right now, but it's a theory. It's just not coming to me right now. Hopefully, we will cover it going downwards, but there's a theory. Anything with sound, we're looking at the theory. And there's also the Doppler effect as well when it comes to frequency and sound. That's extremely important. So it's pretty much all that I like try to know about sound. The Doppler effect, which is mostly physics, but knowing that sound involves sound wave and hair cell. So hair cell, basically, once we have hair, like the hair cell first hit, when sound first hit the outer ear, hair cell plays a big role on us being able to hear the sound. So we are back. I have to take a quick water break. So that's pretty much what I have for hearing. There is a lot when it comes down to hearing, but I just try to know the main thing, which is pressure of sound wave, like knowing what sound wave does, hair cell, and how frequency is important. Different frequency, we're able to hear sound differently because of frequency. Sensation, it's important to know that temperature is thermoception, pressure is mechanoception, and pain is not nociception. I'm pretty sure I'm saying wrong. And position is always going to be proprioception. So pain is extremely important, like knowing that is nociception. It's important to know that this is pain because they could have an article about morphine and it could be like, okay, what type of sensation is this researcher talking about? It's important to know that it is nociception. And when it comes to sensation, you have non-adapting, slow adapting, which means going slow, and fast, which means going very fast. Adaptation is a change over time. As I mentioned before, like you body will adopt, right? You come in, you hear a hospital sound, beep, 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 beep. Eventually, your sound will adapt. You don't hear as much. And that's basically what adaptation is. Like, it's like your body will change over time and adapt. And when it does, adaptation change over time, and you constantly have that same stimuli, it's going to be down regulation. While increase of that stimuli, it's going to be up regulation. First obsession is just looking at balance. We're right here, balance and position. Kinesthesia is talking about movement. As we mentioned before, pain is going to be your nociception. That's extremely important to know. And temp is going to be your thermoception. Temp, thermal, it's in the name. Thermal, temp, thermoception. No susception. We always never want to have pain ever. We always want no pain. So think of it as pain, no susception. And how we sense temperature is we rely on the TRPV1 receptor. There's three type of fibers. This is how I view these actually. Kind of funny. So think of A, right? A beta. If you're an A B student, you're always in your A game, right? So you have fast, thick, covered myelin. You're always in your A game, your AB game. You're an A student, sometimes you're a D student, smaller diameter, less myelin, but you're not too bad. You're not too bad. Now, if you're a C student, you never got A's, small diameters, unmyelinated, really bad. Lingering sense of pain. So now let's move back to taste and smell. So olfaction is every time I think of olfaction, we're thinking about um, is smell. Olfaction, we're always going to think about it as smell. And I think the main thing to know when it comes down to smell is pheromones. So pheromones are basically our scents. Human also have this smell is a way that um, this sense could trigger innate response, could help with mating, fighting, and communication. Other things it's important to know is the amygdala. So this is so important. Anything with emotion, aggression, angerness, amygdala. Okay. Physician wanted to know why this patient is so angry. What part of the brain is it? Frontal lobe, hippocampus, thalamus, amygdala. Emotion, anger, amygdala. Amygdala. You are scared of the MCAT. You have so much emotion. Amygdala. So amygdala is so important. So gestation, I'm always thinking about it as taste. So when we do have gestation, we have bitter, sweet, sour, and umami. Basically, it would taste good to me. So how I remember this is be so sour, you sauce. Be so for bitter, sell for salty, sweet, sour, you sauce. Or you could remember it as be so salty, you sauce. So be so sour, you sauce. Or you could be like, be so salty, you sauce. So it's bitter, salty, sweet, sour, and umami. So be so sour, you sauce. So think about a sauce that you want it to be sour, or salty. And that is the five main taste buds. That's how I remember it. Like everything in the human body, you're gonna have a cascade of reaction. So GPCR is one way that glucose would bind to the GPCR, opening ion channels, causing depolarization. When we have depolarization, that means we're going to have action potential that are going to be happening. So sweet and umami and bitter cell are all GPCR um, receptors. Sour and salty are going to be ion channel. So just think of salty is it's easy to know that because of sodium, and just sour, we want a sour or salty sauce. So ion channel. So they're going to be binding directly to the receptor. So now we are in sleep and consciousness. So the important thing to know about sleep is that there are going to be different stages. And there's also going to be a lot of waves. So beta is associating with awakeness. Alpha is going to be associating with daydream. Theta is going to be drowsiness, and delta is deep sleep. So theta is actually the most important thing you have to keep in mind because it comes off two times in the sleep cycle. Um, yeah, so how I try to remember it is like theta is going to be in the sleep cycle twice. So N1 and particularly N2. Data, I look at it as a D for DE for deep sleep. Data, drowsiness, right about to go to sleep. Alpha, daydream. And beta, if you're a beta person, oftentimes it's the alpha person they think are the best, but beta person is actually the best because they are in constant alertness. So, um, when we look at our sleep states, it's going to go from N1, N2, N3. Then it goes back to N2, and then we have a rapid eye movement, which is very important for memory. So the N1 things you have to know is like they could be like, hey, we're doing this experience in the sleep stage. Patient has increased data waves. Based on our research, what do you think is the stage? You're gonna have to know it could either be N2 or N1. Now, if they say N3 K complex, if they say N3 rapid eyes movement, um, alpha wave, even if they say theta wave, that could possibly be wrong. They're asking for the stage, and there's going to be N2. So N1 is theta, right? Is you're gonna have your strain sensation happening there. You could start hearing things, your first stage of sleep. That is N1, theta. Stage two, deeper stage of sleep, right? But we're gonna have more data. The main thing to know is sleep, spindle, and K complex. They could be like, scientists have increased K complex. What stage of sleep you think it is? N2. It has to be N2. So N2 is sleep, spindles, and K complex. Okay. And three is going to be your rapid eyes movement. Um, Wait, actually, I'm sorry. And three is going to be slow wave sleep, right? We're going to have delta, increased delta. So let's bring it back. N1, theta. N2, more theta. If it says sleep spindles and K complex, we know, listen up, N2 stage. N3 is going to be a lot of delta. Patient has increased delta wave. What stage sleep you think the patient is? N3, nothing else. Um, so it's important to know that K complex suppress cortisol arousal and sleep spindle helps inhibit certain perception. So we are maintain um, our sleep stage. So you can even sleep through loud noise because of the sleep spindle. So you want to sleep through all the loud noise. Now, I could sleep through, I could actually, there was a fire alarm that was happening in my house, and I was so tired. I just slept. I knew I was going to be fine because it was just something was happening when our alarm clock. There was no fire, but I'm pretty sure my sleep spindle came in. I was just like, yeah, go to sleep. Rapid eyes movement is basically where you're daydreaming. It's important for memory consolidation. This is where you want to be for the MCAT. Your rapid eyes movement. You want to dream. I have been dreaming so good. I got a dream I got accepted to med school while studying for this test. That means my rapid eyes movement has been working. So rapid eyes movement is memory consolidation. I'm gonna have a combination of alpha, beta, and desynchronized wave, which is similar to beta wave seen when awake. Um, Circadian rhythm is basically what tells you that you have to sleep. It's a 24 body clock that tells you, hey, time to sleep. Some people get sleepy around the same time. Yeah, it's their body telling them to sleep. Melatonin is what is controlled, and the main thing to know is the pineal gland. This is where it's produced, the pineal gland. Patient presenting with high cortisol because if you have lack of sleep, you're gonna have increased cortisol could happen. Patient present with increased cortisol, unable to sleep. What part of the body is this patient? We're going to be looking for this patient. Pineal gland, melatonin, sleep. Melatonin, sleep. Pineal gland, pineal gland, sorry, pineal gland. You guys get it. So dreaming, there are many theories that tell us why we dream. With Freud, he believed that dreams are just our unconscious thought and desire that needs to be um, interpreted, but there's no scientific support of that. We have evolution and biology. Basically, sleep helps us protect it, helps solve problem, no purpose. That is the evolutionary biology perspective. The most important thing to know is activation synthesis. It's basically saying that our dream have meanings. That is what that means. Our dream have meanings, and there are reason why things are happening. So our manifest content could be like what is happening and the meaning behind it. So example, for me, it could be like, hey, I had a dream actually. I got accepted to medical school, one of my top choice. And, I think the hidden meaning is that Maggie, I was so scared to submit my application. And the hidden meaning of that dream was to submit my application. When it comes to activation synthesis hypothesis, it's basically telling us dream have meaning. Our manifest content is basically what's happening, but our latent content is basically what is the hidden meaning beyond that dream. So let's go to sleep disorder. So when it comes down to sleep disorder, there are many of them. So typically, if you're sleep deprived, you're gonna be annoyed, you're gonna be irritated, you're not even gonna do good at your exam. So please sleep. Don't do all-nighters. I used to do all-nighters back in the day, but it's not worth it. Sleep. So it could be very dangerous. I once heard that if you don't sleep, it's sort of like driving drunk. So sleep is extremely important. And there have been scenario where people just fall asleep while driving. So they are sleep disorder. Typically, if you're not sleeping a lot, your body could be susceptible to obesity. So that means your body's going to produce more cortisol and hunger hormone. Even for me, I could say that increased stress is not good because not only is not good for your body, your heart, your mood, but you have increased sugar and a lot of hunger hormone, and you gain weight. I gain lots of weight studying for this test. So, how much sleep do we need? Typically 7 to 8 hours of sleep. Babies need more. Insomnia, basically, you have trouble falling asleep or staying asleep. So, I think about this is I think about insomnia cookies. Like, I love cookies so much that I don't even fall asleep. So, insomnia cookies. I love cookies so much. I want to get Asomia cookies, order online, and I don't want to fall asleep until I get my Asomia cookies. So Asomia is you have a hard time falling asleep. Narco, I think about the Migos song, straight out the Narco. Yeah, 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 yeah. So you just can't help yourself from falling asleep. I love Migos so much. I am I am like, I can't just help myself from falling asleep. Like, yeah, straight out of Narco. I cannot help myself from falling asleep. Hopefully that makes sense. So, like the name, like I love Migos so much, I cannot help but fall to help myself fall asleep. That's just a way of me remembering it, but it may not make sense to you. Sleep apnea is basically people just have trouble with sleeping where they stop breathing while sleeping. So they don't get enough N3. And when we don't have enough N3, that means we don't have a lot of delta waves. Sleepwalking is basically when you're walking in your sleep. It's going to be incurring N3. And when we have N3, the wave is going to be delta waves, and two, theta waves. Sleep spindles, K complex, and one, theta wave. Let's see what we have next. Sleep apnea, just a hard time breathing in sleep. Hypnosis, it just involves people relaxing. Dissociation theory involve hypnosis, just extremely form of divided consciousness. Social influence is that people tend to do and do what people expect of them, kind of like actors being in a role. Meditation is basically just finding a way to be aware and have attention, and this is very helpful for aging and ADHD. Now we are into drugs. I am going to take a quick break. Let's pause. So we are talking so first thing is like depressant is always going to be lowering your body function, and things that are depressant is alcohol, barbiturates, benzodiazepines. These are common depressant, and if when we're talking about opioids, things to keep in mind is you're gonna have heroin and morphine. So depressant basically just lower your body basic function and neuroactivity. So think about alcohol. Like, yes, you're happy, you're at the club, you're having a great time if you go to the club, but at some point, like it's a depressant. It lowers your body and neuroactivity. You know, some people get so drunk like they don't even remember anything that happened. So just think about it. Depressant, lower your body basic function, especially neuroactivity, where you're just blacked out, where you don't even remember anything if you drink way too much. Barbiturates induce sleep or reduce anxiety. Um, Depress your CNS. So when it comes down to anxiety, people are constantly thinking, like they're anxious. So this drug basically depresses your CNS. Benzodiazepines is a common suppressant. It's important when it comes down to sleeping. So if you have a trouble sleeping, this will help. If you have anxiety, this will help with anxiety, anti-anxiety. What it does is it increase your GABA. So there's a difference between glutamate and GABA. So GABA typically um decrease while glutamate is incitatory. How I think about it is glute, when you're working your glutes, you want it to get excited and get into the exercise, while GABA decrease. Opioids are usually used for pain and anxiety as well, but typically pain. So heroin and morphine is extremely important, especially when it comes down to morphine. When I was in the ER, morphine was used a lot, and we do have pain medication problem that's happening in the United States, especially in the healthcare system. But morphine is just one of those really good drugs that helps patient with pain. But it's important to be careful when it comes to those drugs because they could be addicted, and you don't want to give patient um, pain medication that are addicted to it, but you also don't want to not give patient pain medication because of what's happening in the healthcare system right now. Especially, I'm thinking about patients that suffer from sickle cell anemia. Like they have, they may some patient that do suffer from sickle cell anemia may have high pain tolerance, and they do need the pain medication to feel better. So opioids, heroin, and morphine. So how they treat pain is that they act on the body endorphins. Stimulants is going to be your caffeine, your cocaine, your methamphetamines, and amphetamines. So they're just stimulants. They they give you increased um, neural activities and bodily function. Especially when we're thinking about caffeine. Sometimes if you're so sensitive to caffeine, you want to poop, right? Because it's a stimulant. It's increase your body function. It works uh, with the digestive muscle to let you go. Some people, if they're constipated, they will just drink coffee, a lot of coffee with milk, and they will go. So stimulants will increase neural activity and body function. I remember studying for like the MCAT, and like I drink a really good coffee and I did so well in my section rank. And I was just like, it's because of the coffee, because my neural activity increased. Hallucination, these drugs will alter our perception. So patient will hallucinate, will see things, will say things, will feel things that may not be there. So ecstasy is one, LSD is one, and marijuana. So typically, these will increase, especially for ecstasy, dopamine and serotonin, and LSD will interfere with serotonin. And marijuana, one thing that you have to know is the main chemical is actually THC. So marijuana has changed. A lot of things in healthcare. There are now doctors that specifically specialize to work with marijuana. So things have really changed, but the main active chemical is THC, and it is a hallucination. So, drug dependence and homeostasis. So, homeostasis is so important. It's basically how we maintain our body. Hormones is what we use to communicate, and it plays along together with homeostasis. Our body wants to maintain correct equilibrium, and how it does this is metabolism, your temperature, your heartbeat. So, if you're cold, you will start to have, goosebumps, right? And that's just your body way of keeping you warm. If you're hot, you're gonna start sweating. That's the way of your body keeping you cold. Well, it's kind of the same thing with drugs as well. Like your body could get used to a drug and it wants more and more and more and more. Um, and especially with drugs, is that you have to be careful where you take it to. Like a person could, take a drug in a room, right? And they understand the cues, they understand everything that goes along with taking that drug in that particular room, but they go to another room and um and they take the drug for the first time in a new room and they just take it more and more and more and they could go overdose. So I always think about celebrities that die in their hotel room because of drug overdose. And what I came to a conclusion is that they were not in the area of their home or their their singing bus, the bus that they take to go when they have their concert, they were not in those areas. They were in a hotel room, which required them to take higher dose because their body did not recognize the external cues, like, hey, we're gonna expose ourselves to this drug, and they just wanted more and they got higher dose and that's why they end up having an overdose in a hotel room. I just think about Whitney Houston for some reason when I learned about drug dependency and the importance of where you take the drugs. So there are various routes of entry when it comes down to taking drugs. So we're gonna have oral is basically you taking it by mouth, inhalation is when you're breathing it. So think about marijuana. They have people call it a blunt. They like roll the blunt and they inhale it. Ejection is when they directly put it into the vein. It's actually very dangerous. Transdermal, it's in the name transdermal, going to the dermal skin, your skin. Your intramuscular is going through your muscle. And it's important to know the award pathway, and it's going to be your VTA, your ventral tegmental area in the midbrain. We have amygdala again, emotion, 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 nucleus. Incumbents is control of motor function. Prefrontal is always going to be your focus and tension, and your hippocampus is always going to be your memory. We sort of talk about tolerance and withdrawal. Tolerance is just basically your body is just used to the drug, and because it's so used to it, it always want more. So sometimes the drugs won't have the same high because the receptor has shut down and it just wants more and more and more. So your body has to tolerate it. Now, if you go a period of time where you're unable to get this drug, you're gonna go to withdrawal symptoms. Typically, patients that are going to detox are going to withdraw symptoms so that way they don't get this drug. So I'm sorry. So that way they don't get addicted to this drug again. So withdrawal symptoms are going to start happening during detox. So taking the drug out of the system to shut down the receptor. Um, so substance use disorder. Um, So the substance-induced disorder, where it plays along with the mood, like mania, depression, anxiety, sleep, sexual um, function, psychosis, and we also have substance use disorder, which just basically impair your life. Like you cannot do anything. You always have to have the drugs. Um, and that impairs, like it's gonna be your work, school, and home. That's gonna be impaired, and other things as well. Substance use disorder. Withdrawal is basically you don't have this drug, so your body wants it, and you're just going to withdraw symptoms. Tolerance is how much you could tolerate this drug. So some people have high tolerance to pain medication, as we mentioned. Patient with sickle cell, because they're constantly getting this drug, they're always in pain, so they do have high tolerance for the drug. So it's just extremely important to pay attention to those patients and help them as much as you can. Oftentimes, people might think they're drug addict, but they're not. They just have high pain tolerance. So um, but it could also be a high tolerance um, for drugs. Like some patient may just want so much high, like their body needs this all the time. There are different ways that patient could get help. So this is extremely important. So cognitive behavior therapy, just not even for drug treatment, but it could also be used for depression or any other mental health disorder, is looking at the cognitive behavior component of the addiction and figure out ways that we could change our behavior to better help these patients. Motivational interview is now becoming extremely popular now, not just for drugs, patient going to detox, but these are also important in primary care as well. It's basically working with the patient intrinsic motivation to change. Group meeting, as you can see, you typically see these in movies, is going in a group talking about ways that they are going through these drugs, addiction, their acceptance, actively um, going to these meetings to talk amongst each other to get better. They're called AA meetings. Relapse is when the patient unfortunately go back to drugs, and it then becomes more addictive substance because more addictive substance is most likely to get relapse because it's just so hard for your body to stay clean, especially if you've been doing it for years. It becomes so much harder. So now we're going to be talking about intention. Um, Things to know about attention. So we have different type of attention. Um, Divided attention is when we're looking at two things at once and we're having to like switch tasks, but we're not actively focusing on it. Exogenous is we don't have to look within ourselves for it. We just happen to see it like a loud noise. Like endogenous is that is internal knowledge to understand the cues that are coming in. So it talks about the cocktail party. So imagine you're at a party and someone shout your name and you just turn around. You're able to understand that cue because it requires internal knowledge. Like, hey, that's my name in the middle of the crowd. Unintentional blindness is basically not being aware um, of the feel and attention. So you're unintentionally blind. And then change blindness is just to fail to notice change in the environment. Like if I give you a globe and there is a water bottle next to it, and I give you the first picture of the globe, there's no water bottle into it. And I give you the picture again, and there's a water bottle into it. And you are unable to like notice it, that's going to be like change blindness. Fail to notice change in that environment. So fail to notice change in that picture. Shadowing tasks is extremely important, and there's different ways the MCAT will act. So the left ear, one thing, and the right ear, one thing. So shadowing tasks is basically having a headphone in your ears. One ear is going to be hearing another thing, and the other ear is going to be hearing the other thing. You have to repeat it, and you have to ignore the other ear. Shadowing tasks involve ears and hearing something going to the different part of the ears. That's how I view shadowing tasks. So they could be like, we're having an experience where a patient had to hear something on the left side and they have to ignore something on the right side. What do you think is happening? Are you going to be patient is undergoing shadowing tasks? So there are different memories when it comes down to um, registering and filtering information. So the broadband um, is one of them. So broadband is basically all information in the environment will go into sensory registration, right? And then it will get selected filter. So what's going to happen is that our perceptual process will identify what is happening. The problem is if we completely filter out like information that we don't want, how do we really know to identify our name? So that is basically what that theory is. The Dutch theory focus on selective filter decide why we pass on to conscious awareness. But giving limited resource and attention seem wasteful to spend all the time assessing meaning to things first. Transmen just focus on selective filter, just weakens. So the selective filter weakens, but doesn't get eliminated. So there are different things when it comes down to multitasking and spotlight or attention. So priming is when we first get exposed to that stimuli. Um, so that's just basically what it is. It's just basically when we first get exposed to that stimuli. Resource model of attention is that we have limits of resource and attention. Multitasking is just doing different things all at once. So when it comes to multitasking, task similarity is really good. So if it's task similarity, you're easier to multitask. For example, um, you listen to music while writing a paper. Um, if it's a music that is classical, like it'll be great because you can multitask better because it's similar tasks, like it's quiet, it's calming. Some people could listen to Cardi B and still write a really good paper, but it's just really good to have the task that's similar um, because it's just harder to multitask doing something that requires a lot of focus. Task difficulty happens when we're having harder tasks and like it requires like more information, like more focus. But if the task is like similar, and you're used to writing a bunch of paper, like you're able to do well on it. Um, just like if I am you know, driving and I want to listen to my lecture, I could do that. Why? Because I drove all the time. I I'm listening to a lecture. I'm re-listening to a lecture that I know. So text similarity, like that will work. But now if I have to solve a very hard, complex math problem, there's absolutely no way I'm able to drive and solve that hard problem. So harder tasks will require more focus, while tasks are similar to you, doesn't require a lot of focus, like more focus or strong focus. And practice is always helpful when it comes to doing tasks or learning. So memories. So when it comes down to memories, we do have things that are very important to know is that iconic is what we see and econic is what we hear. So working memory is think about um what you are thinking in that moment. You have to work to get that memory in a way. And it's important to know the magic or 7 plus 2, which is why it's like you could remember a phone number really well because of 7. But if it's longer than 7, it's going to be extremely difficult. Explicit is going to be called declarative, and implicit is going to be called non-declarative. It's important to know that explicit explicit memory is declarative because they could have two interchoice, declarative and explicit. So if you know it can be two interchoice, you could delete that. So expressive is going to be declarative, implicit is going to be non-declarative. Expressive are facts and events. Implicit involve things you cannot articulate, so like riding a bike. So procedure memory is one of them. This is how we learn. So encoding is when you first get the information and rote rehearsal, you may say the same thing over and over again. It's not effective. Chunking is when we group things into meaningful categories. Mnemonic is basically trying to remember things based on a sentence or an acronym. Self-referring is thinking about new information and how it relates. So teaching is how I'm doing it, preparing to teach the material to somebody or organizing the information like a mind maps is self referencing. Self refer referencing. Spacing is just spreading the information over time. So think of Anki. So priming is basically having prior information. So in association with whatever you're learning. Context is just the environment that you learn the information. So if you're taking a practice test, it's important to make sure you're taking that practice exam in the environment that you're going to be taking it in full length. So you want to be in a quiet area. You want to have your breaks, your short break, your long break. So contest is basically what it's talking about. Stage dependency memory is basically you are remembering memory based on your state. So if you smell something so good, a perfume, and it brings back memories to your childhood, that's like a state dependency memory. Free recall is no cues in recalling. Cues recall is you have a cue. So like if I said PL for planet, that's just me giving you a cues. Recognition is just remembering things, basically. Presenting two words, tell me what it is. Can you recognize it? Can you remember what you hear? False information is in the name, inaccurate recollection of the event. Misleading information is thinking you saw something, but you haven't saw something. So it's misleading information. Similar to source monitoring error, memory error, where source memory is incorrect when it comes down to a collection of things or a memory. Emotional memories is basically remembering things based on having high emotions. So I think of myself when I heard Michael Jackson die, where I was so happy to have McDonald's, and then I opened the TV, heard Michael Jackson die, and I still remember that memory. So it's high vivid memories based on positive or negative emotions. So it's just flashbulb memories that you remember based on having strong emotion towards it. Synaptic plasticity is basically connection between neurons increase. Decay is when we don't encode something at all or remember something for a while. So when it comes down to retroactive. So retroactive is learning and impairing old information. So I think of retro back in the day, Proactive is learning something you learn like in the future. So you're having issues, it's a past impairment based on the future. So retro, back in the day, learning impaired information. Proactive is learning, is having issue with past information. Stable, improve, decline, stable. That means your memory is stable, improve. That means your memory start improving when it comes down to like age. So like stable, so typically with aging, implicit memory is still there, like riding a bike. So aging, implicit memory, improve. You could have some somatic improvement around age 60, but crystal IQ is extremely important. So crystal IQ is what crystallized IQ is the type of memory that tend to improve as aging. Decline is just episodic memories tend to decline because you are forming lots of new memories. So the old memories just forming new memories is difficult, but like old memories is stable. Alzheimer's disease, to keep it short, your neuron starts to die off. The main thing to know is amyloid plaques in the brain. Korsakoff syndrome is like a B1 timing. So every time you see Korsakoff timing is vitamin B1. Retro, like as I mentioned, retro is back in the day, retrograde back in the day, like retro music back in the day. It's inability to recall previous encoded information. Intro means I'm going forward, interior, like intergrade amnesia is basically you're unable to encode new memory. Piaget, things you have to know is sensory motor is going to be from 0 to 2 years old. So we could have a research project that's happening. We're testing students that are from 2 to 7. What type of stage would this be? Pre-operational stage. Concentrate operational stage is going to be 7 to 11. Formal operational stage is going to be 12 and up. So things to know is that sensorimotor stage, we're gonna have issues. Also, we're gonna develop um, object permanence. So you don't really realize an object still exists if you can't see them. Pre-operational stage 2 to 7, things we have to keep in mind is it's going to be a lot of egocentric and pretend play. Concrete operational things to keep in mind is they're going to be learning about conservation and also begin to learn empathy. And from 12 years and up, formal operation, they're going to have more abstract thinking, more reasoning, and consequence. So if there is a study being done and they're saying this age group that was tested in the study, I'm going to go back to see the age group in the study and I'm going to be like, okay, if it's 7 to 11 years old, then I know my answer choice should be concrete operational stage. They're not going to be like, what is this stage for 7 to 11 years old? They're going to say, in the research, what stage do you think this could be? You have to go back to the research, look at the stage, and then boom, you pick up your answer through there. Let's see, how many do we have? Okay, we're going to stop right here because I don't want to make the video way too long. So we'll pick it back up on cognition.